Welcome everyone. So this is our 76th live stream geometry. I have one other person here with us, and today I'm going to go over problems that I found. So 2 sessions ago, we did some problems created by Jean Louis Ayme. So he's a retired professor from France, and he's also a pretty frequent poster on the Art of Problem Solving forum. So I looked through some of his posts. I'm going to do some of the problems that he proposed, and I'm going to do some problems that other people proposed, but that he found a solution to. So if you want to join us in the future, feel free to email me at mgreenb801@gmail.com. It's in the description of my video. So we meet every Sunday at 8 a.m. US Central Time. So with that, I will share my screen. All right. So here's the first problem. So this was posted by France666. So I'm not sure who that is on the Art of Problem Solving forum, but it looked kind of interesting. So we have a triangle ABC, and O is the circumcircle. So I'm going to draw that. So this problem looked really similar to the very first problem I did on my channel. I think it might be a generalization of it. So we draw the angle bisector BAC, and M is any point on it. So let's shrink this just a little bit. So we draw point M on the angle bisector, and then we draw the feet of the perpendicular from M to A, B, and AC. So first I'm going to label the midpoint of BC, that's I. So that's I. And J is the midpoint of arc BAC. So I'm just doing kind of this out of order. So this is J. P and Q are the projections of M onto A, B, and AC. This is P. This is Q. So H is the projection of I onto PQ. We want to show that M, H, and J are collinear. So yeah, I wonder if, I don't know if the first problem on my channel, M was like the foot of the angle bisector or something, but so maybe it has like a similar.
M was the in-center in that problem.
Ah, M was the in-center. Okay. So maybe this has a very similar solution to that, because let me draw this point. So we have the angle bisector. So yeah, this is a generalization of that. So when I did that problem, it was like I said, like, I think I try to show MA over AJ is like D this over this point to J. Like I try to use ratios like that. So why don't I try defining this point right here? And basically, I want to show MA over AJ is DF over FJ. I'm not sure if that same idea will work this time. And DF is equal to AG, of course. But F, so really it would be MA over AG. But these are like, these are like right triangles. So MA over AG, maybe I could do something with that ratio. But how do I get AJ? So AJ, I know information about, but what about FJ? We know FJI is
FJ doesn't, when you move M, F doesn't change.
Oh, good point. So, yeah. So we have FJ. Yeah, it doesn't move. So FJ over JI is AJ over JE. So yeah, actually, JF over JA is JI over JE. So we just have to show that JI over JE is AG over AM, I think. And that looks just like similar triangles. So yeah, I think that solves it pretty much. It's an easy one. Well, it's easier because I did the problem before, the more specific problem, but I think that does it. So JF over JA is equal to JI over JE. So I'll define the points in the end, but we have that, and then AM over AG. I mean, the whole figure JBE is similar to APM, right? So I'm going to fill in the details in just a second, but JBE is similar to APM, and G is the altitude from, I'm sorry, APM. So that basically implies that JI over JE is AG over AM. So yeah, this is too easy. Too easy with what I already knew from the previous one.
I think this is exactly the same like before then.
Yeah. And so, sorry, AG over AM. So since JF over JA is equal to AG over AM, then that implies that which is FD over AM. So we have JF over JA equals FD over AM. That implies MH and J are linear. Now let me fill in some of the details. So let the
you named the pointed D here in the diagram. Pointed D should be H.
D should be H. Oh, you're right. So I'm gonna change that. Okay, so we already defined that. We just need to define, let G be the midpoint of PQ, and let F be the intersection of IH and AJ. IH intersect BJ at F. Then AGHF is a rectangle. That's pretty clear, so I'm just going to write that. Let E be the midpoint of arc BC. Okay. So AGHF is a rectangle. And then, yeah, I'm just going to prove this similarity really quickly. So we have angle BJE is half of BJC. Actually, it's just BJE is BAE, which is PAG. So yeah. PAM. And that pretty much does it, because those are both right triangles. All right, so I will move on to the next one. I think they will probably get harder. So this is by Jean Louis Ayme himself. So we have a triangle ABC, and we draw the circumcircle and the incircle. I don't know if we actually need the circumcenter ever. Oh, whoops. I'll just draw it because I just did. Okay. So I could just say, I'll just draw it. Why not? So then we take the perpendicular to BC through I. So that passes through the tangency point. And we want to see where it intersects the arc. So the arc BC, which doesn't contain A. All right. I'm going to draw it through the tangency point. But I'm going to have to rename this. Call it P. So this is D. And then we draw the intersection of AD and BC. We call it E. Let's see if I can draw that. Whoops. Yeah, it's a tricky point to draw. If I let's see if I can draw it like that. There we go. That's E. And then we draw the intersection of O and AIE. So this point right here, calls it A star. Yeah, it doesn't like, how do I draw A star? Let's see if that works. But it's a subscript instead of a superscript. Oh well. And then the midpoint of arc BAC. I think we just want to show that A star is, yeah, the point of tangency of the mixed linear incircle. So this is A plus,
It is unnecessary to draw that point at all.
Yeah, but basically because we just want to show that this is the mixed linear tangency point, right? So we don't really need a plus, I guess. Okay. Yeah, so I don't know if there's like a well-known thing, although I don't know the proof myself. I think there's like some theorem that says that if you take the point of tangency of the mixed linear in circle and you connect it through P, then it's like parallel. This segment's parallel to BC. So maybe we can draw this point, and we could try to show that AF is parallel to BC.
Oh, I think that it is sufficient to prove that A star EPD is cyclic.
Oh, really? Okay.
Yes, when using that fact about point F.
Okay. Interesting. So we want to show that this is a right angle. All right. So basically, we want to show that angle EPA is angle EDA star, or EPA star is EDA star, which is ADA star. I'm probably just working backwards. I wonder if DI is tangent to the circle. It kind of looks like it is, but I'm not positive. Yeah, I think DI is tangent. I guess we could try to show that DI squared is DE times DA. Maybe we could try to use the radical axis theorem too. Like, what if I drop a perpendicular from I to AD? Then we'd have one cyclic quadrilateral, another cyclic one, another one that we're trying to prove is cyclic. I'm going to just try this. So G would be like the midpoint of the segment. Actually, so if we have IGAD, Yeah, what if we take those two circles in the big circle? So actually, yeah, point E kind of looks familiar. I think I might have seen it before. So one thing we know, and I don't know if this helps, but maybe I could draw the midpoint of arc BC. And then this point is cyclic with those 2 points, but I'm not sure if that helps that much. But yeah, I feel like I've seen point E before. I just don't remember exactly what to do with it. I don't know if drawing the mixed linear circle would help. So yeah, we want to show this is cyclic. So we want to show this is a right angle. All right, looks like we have Serdar joining. Hey, Serdar, thanks for joining.
Hi.
Was Turkey in the Junior Balkan Math Olympiad?
Yeah.
Were you in it?
No, I am not junior.
Okay. So yeah, this is our second problem. The first one was basically a generalization of the very first problem on my channel, and you could kind of solve it the same way. So that was pretty quick. But this one looks like it's just might be just some like fact about mixed linear in circles, but I haven't seen it before. Yeah, let me change this to be prove A star. There we go. So yeah, basically we define this point A star. So we drop the perpendicular from I to BC and it meets the circumcircle at point B, and then we let AB intersect BC at E. And then basically if we draw the circle AIE, we want to show it meets the circumcircle at the mixed linear in circle tangent C point. So yeah, I mean the way they phrase it in the problem is prove that I and this are collinear, but that's the same thing.
Can you name the midpoint of arc BC?
The smaller arc BC, yeah.
Yeah.
I think I might have drawn it before, yeah, and then I got rid of it. Okay. Yeah, I guess we can just leave it as H.
I think it's better to define A star as mixed linear touch.
Yeah, I agree. We could just say prove that this is the mixed linear touch. Or do you want to just define A star as the mixed linear and then prove that that's cyclic? Is that kind of what you're saying? Yeah. All right. Do you want me to draw? So yeah, we know a couple things. Do you want me to draw the mixed linear in circle, or just we know that that's what it is?
Yeah, we don't need circle.
Okay. So yeah, instead of A star, I could call this a I'm running out of A minus. There we go. Let's see. I don't know if it's worth trying this. Is this an angle bisector? I don't think it is.
Oh, we want to prove that IE is parallel to A plus D.
Oh, really? That's interesting. Yeah, maybe projected geometry or something. So yeah, we know for angle IEP, yeah, I think this might be an angle bisector. Let's see. Well, it's kind of hard to tell just doing that. Why don't I do this? This will tell me whether it's the case. Oh yeah, pretty sure it is. So yeah, it looks like A minus E bisects that angle. And I don't know if that would like solve the problem or not. But yeah, that's kind of interesting because it means basically if we draw this and then we draw this, yeah, we're saying that this is like parallel.
We intersect A plus with BC.
H or A plus
A plus and A.
and A. Yes.
And DH, I guess DH passes through that point.
Okay. No, I don't think so. Do you want me to draw DH or just that?
No,
Okay.
there was another line, I guess.
Okay. Maybe does IG pass through J? No. Does DH pass through that point? Yes. So IG, DH, and BC concur. I don't know if it's worth drawing that. I don't know if that's like obvious by the radical axis theorem or something.
If we prove that they intersect at K, then we are done because it implies IE is parallel to A plus D.
Ah. Is E the orthocenter? So E is the orthocenter of if we know they concur. So yeah, that would prove it. Okay, so we have to show that these three concur. So is there another circle through D and H that we can use? It almost looks like that's cyclic. I don't know if that's, no, actually I don't, yeah, that's not true. I draw this. You know, that's cyclic.
And delete segment IK. Maybe it's better to prove that IK is perpendicular to AD.
Okay. Hmm. I wonder if it's pole. Yeah, I don't know if it's that easy to just use pole and polar. Let's see, maybe this is cyclic. No. Yeah, no. Or maybe I could draw it like through DH in the midpoint. That might.
I think I know how to solve it.
Okay.
So basically we have that HD times HK is HI squared.
Okay.
That is, I mean, well known. And we can then deduce that angle HID is equal to HKI.
Okay. And then it's kind of an angle chase to show that they're perpendicular.
Yeah, because we can calculate angle ADK, because that is HCA and that is an angle we know.
So HD times HK is HI squared. So well, HI squared is HB squared. Well, basically, I think if we draw any line through H and we let it intersect BC and the circle, then we always have it that when you multiply the two, it's HI squared. Is that right?
Yeah.
So yeah, because basically, so yeah, I think you can use inversion for that, or the idea is that.
Yeah, you can invert, because inversion about the circles at centered at H and radius HB swaps this circumcircle and line BC.
Yeah. So yeah, here's a way, I think this is equivalent to inversion, but basically A plus L dk is cyclic because A plus dk is 90 degrees. So HD times HK is HL times HA plus, which is HB squared, which is HI squared. Okay, so once we know that, then we know angle HID is equal to angle HKI. And then from there, it's just angle chasing, I think, right? Okay. So let me write it up. Let DH meet BC at K. Let L be the midpoint of BC. So, let's see, Serdar. Okay, thanks, Serdar. So, all right. I like how the pluses make it confusing. Let's see how this comes out. Oh, that's not so bad. There we go. Okay, so IKD plus, yeah, so angle ADK equals 90 equals angle ALK. Cyclic. And so HD times HK is HL times HA plus. Is HB squared, which is HI squared. Squared. All right. There we go. So that means that angle HIB equals angle HKI. Then we have that angle chase. So IKD plus ADK is DAH. So IKD is HID. And HID is DAH plus AHD plus DIH. So D A plus H plus I H A plus. I'm just kind of assuming this works out because it's half of because it's this arc plus this arc plus this arc. Yeah, so yeah, that means IK is perpendicular to AB. So, all right, we have someone else joining. So that implies E is the orthocenter of IKD. So E is the orthocenter of IKD. Thanks for joining, Animika. And so that means that IE is perpendicular to KB. So IE is parallel to A plus D. Perpendicular to KB. And that means IE is parallel to A plus D. And then how did, so does that show that this is cyclic? I forget how that finishes it.
It's Rime's theorem.
Rime's theorem. Okay, so once we know that those are parallel,
A plus IE, A minus IE equals to A minus A plus D, and it equals to A minus AD.
which is A minus AD. So that
This
shows
is A minus AE, so angles are equal.
Okay, so then that shows that this is cyclic. So we have, okay, A minus IE. IE is equal to A, sorry, I hate this A minus and whatever, but oh well. A minus A plus D, which is equal to A minus AD. And that implies A minus AIE is cyclic. And that implies A minus equals A star. And that implies that A star I and A plus are. All right, let's see if that all fits on one line. Get up into 2. Let's see how that looks. All right, I think we're good here. Let me just do one more thing. So I'm gonna say let A plus I meet the circle at A minus. All right, yeah, thanks for waiting through all this. Okay, so I'm going to move on to the next one. Okay, so we have the triangle, we have the in-center and the orthocenter, and then we have the midpoints of AC and AB. So let me draw the in-circle and the orthocenter. Okay, let's close this. We draw the midpoints of AC and AB. Yeah, I'm not as big a fan of the notation, but yeah, it's not so bad for this. And then, yeah, C prime kind of looks like the tangency point, but I'll fix that later. So we draw the perpendicular to AB through I. So, okay, so we want C. Okay, so this will be F. Just I'm that lazy. I don't want to rename stuff. And F prime is the reflection of F over C prime. And then X is the intersection of BH and B prime I. Okay, so I think X is a point kind of far away. BH and B prime I. Oh, actually not really. Yeah, it's not that far away. So let's draw altitudes. We want to show that F prime X is parallel to AI. So H, do we even need H, or that's just the perpendicular? Yeah, we don't need H, right? That's silly. Yeah, maybe this is an easy problem. I think there are harder problems though. So yeah, if we solve this quickly, yeah, I'll try to see if we can find a harder problem. But it looks like.
Can you check it?
Can I what?
Can you check the problem if the problem is true?
Oh. Because yeah, it looks like. Let's see. I think it's probably true. I guess what I could do is do it like this, but yeah.
Could you rotate the triangle? I think having C on top is better.
Yeah, I agree. Yeah, that's more, because then F prime is the X center, the C X touch. This looks a lot like the Iran lemma, right? But it's different. It's like the X circle instead or something.
Can you name the tangency point of AC and in circle?
Yes.
Also, can you intersect DI with in circle and reflect D across B prime?
So reflect D or intersect DI with the in circle?
Yeah. And draw the line BD prime.
B, oh, this line. Oh, okay. See if it passed through G basically.
It's well known.
Okay. Oh yeah, of course. Yeah. Yeah, this is parallel to this. Then this is, so yeah, this is a parallelogram.
It's enough to prove that. Sorry, I forgot it. Wait a minute. It's enough to prove that EX F prime equals to D IDA FDA.
EXF prime equals FDA.
Because if we show it, then can you name the point of intersection FD and F prime X?
Yeah.
If we show that angle, then we will have XED equals to FJF prime, and XED is 90 degree.
Okay.
So it's enough to prove that EXJ equals to DIA.
Okay.
I don't know the rest of it.
Yeah, so we know FD is perpendicular to IA. We want to show EXF prime is.
Never mind, I assumed the problem is correct and then proved it.
Let's see. Maybe we could use projective geometry. We know C prime is the midpoint of those two. Okay, let's think about this. Oh, one sec, guys. We'll be right back. All right, I'm back.
Can you delete this segment xf prime?
Yes. Oh, yeah. I don't know if it's worth trying to do the same thing with f prime that we did with d prime, where we kind of do it like this. Actually, you know what? Let me just do it like this.
Can you draw f prime, b prime?
F prime, b prime?
Yeah.
Or do you mean f prime, d prime?
No, b prime. That's correct.
Okay. So looks like Min just joined us. Thanks for joining again, Min. Yeah, I think you might have gotten cut off before.
BD prime and XB prime are parallel.
BD prime and XB prime are parallel.
That is by IM lemma.
By the IM lemma. Yeah, because yeah, I is the midpoint of GD and B prime is the midpoint of DD prime. So yeah. But yeah, we still have to use the IM lemma to show that BG and B prime are, yeah. So yeah, we know this is a parallelogram right here. See if we can use ratios maybe to. So I wonder if we can let this intersect AB. And we want to show IX over IL. Wait, how does this work? Or X. Yeah, I wanted to use this as a parallelogram, but I'm not sure how easy that is. Or IX over AF. Sorry.
Intersect AI with BE.
Okay, AI with BE. All right.
Then using ratios looks very good.
Okay. So we want to show that that's parallel. So basically we want to show that mx or bm over bx is bf prime over ab. Is that kind of what you're thinking?
Those ratios are not that good, but bf prime over f prime a is really good.
Oh, bf prime over f prime a is bx over xm.
That is good since bf is equal to af prime. And
okay. So let me delete L. Okay. So bx over xm. So bx is equal to the in radius, right? Because bx is equal to ig. And xm, so we want to show that the radius over xm is equal to bf prime over f prime a, which is the same as af over fb. So yeah, how do we find xm? That's the key.
I solved it using calculations. I will write it down now.
Okay.
Can you name the intersection of b prime, f prime, and ai?
Okay. So yeah, instead we could, like, I'm just thinking Stefan's idea. Bx over bm might be good because bm over me is ab over ae. Oh, you know what? I think we can solve it using Stefan's idea. But yeah, so maybe I'll write out both of them. First, I'll write out Serdar's solution. Then I could do it Stefan's way. So yeah, bm over me is ab over ae. And we want to find bx over bm. And we want to show that, yeah, Stefan's, let's see, so AE. And we want to show bx over bm is bf prime over ba. But bx is equal to the in radius. And we also have me over id. So me over r is equal to AE over AD. 1 second. So if we combine these, okay, so Serdar. Okay, so first I'm going to do Stefan's way, and then I'm going to do it Serdar's way. So we also have BF prime over BF prime is equal to AF. And we have BX equals IG equals ID. And if we combine all these, I think we get the ratio we want. So we want, what do we want? We want BX over, or we want BM over BX equals AB over.
Yeah, you can just multiply the first two equalities and you will get what
you want.
what is needed. Yeah.
I'll say so combining the above, we get that, which implies fx prime is parallel to AI. Okay. And then I'm going to write what Serdar's solution. So where did I use that BF prime is? So you just combine these and then, but where does BF prime equals AF come into play? Okay, so let me think about this. So ME. Is it? So where does, so BF prime is AF. Oh, because AF is AB. BF prime equals AF equals AB. Okay. So that's the first solution. And then I'm going to write what Serdar has. Sorry. Just going to type it in the chat. All right. So BD prime over DE is equal to B prime L over LF prime. LF prime is B prime D. Well, so that would show that DL is parallel to EF prime, right?
We know that B prime D over DE equals to B prime I over IX. So it will be what we want.
So yeah, it's basically like a homothety. A homothety takes these four to these four. Okay, so yeah. So the right side, we can calculate that. And the left side, You probably know. Yeah, that's just the angle bisector theorem. And then this is, we can just use that it's ID over XE. And then that solves it. All right, so I'm going to move on to the next one. So we've gotten through 3. So